So this is exercise 1.2 on the trapezoidal rule. The diagram shows part of a circle with center 0, 0, and the curve is represented by the equation 25 minus square root of y equals the square root of 25 minus x squared. What it says is calculate the values of y correct to 2 decimal places. So what we can do here is we can do the table mode on the calculator, and we can do f of x, which is y, equals the square root of 25 minus x squared. On completion of that, we can do it from 0 to 5, so 0 to 5, step of 1, and we can have 5, 4.8, 4.9, so 5, 4.9, and then for 2 we have 4.6. I'll correct the 2 decimal places, so 4.58, excuse me, 4.58, and then we have number 4, which is going to be which is number 3. Okay, so this here's number 3. Now, is this an overestimation or underestimation? It's considered to be an underestimation. I'll tell you why. So if we're to divide this up into equal parts like so, what the trapezoidal rule is doing is it's basically, if we were to draw lines going upwards, the trapezoidal rule is basically calculating the parts in here like this. So what we're doing is we're cutting off certain points at the top. So as this comes around, that's what the trapezoidal rule is calculating, just these little areas here. So we can see that there's a shaded in region that is going to be not used, so it's going to be an underestimation. Okay, it's the answer for that. So calculate the y values correct to 2 decimal places, and we're going to use the trapezoidal rule as well. Now, what is the trapezoidal rule? Well, the trapezoidal rule is So the trapezoidal rule. Okay, so the trapezoidal rule is basically it's basically h over 2. Now area equals h over 2. H stands for the width. So in this question, h equals 1. Okay, y1 stands for the first height, which is 5. So y1 equals 5, and then we have yn, which is the last height. The last height is basically, so that's going to be y1, y2, y3, y4, y5, and y6. Okay, so and then y6 equals 0. So what we're going to have for this trapezoidal rule is a equals a half y1, which is 5, plus yn, which is 0, plus 2 times the remainder. So 2 times the remaining heights is going to be 4.9 plus 4.58 plus 4 and plus 3. Close bracket. Now we're going to use this in the calculator to figure out the area. Okay, so it is going to be 0.5 or a half multiplied by 5 plus 2 times everything in this bracket, which is going to be 4.9 plus 4.58 plus 4 plus 3. Close bracket, close bracket. So the answer here is going to be 18.98. So area equals 18.98. I just want to see what the measurements are in. Just 18.98 units squared. Now, the next thing we're asked to do is we're asked to use the trapezoidal rule with 10 intervals to estimate the shaded area. Calculate the values of y correct to 2 decimal places. Well, what happens this time is, instead of using these areas here, what we're going to do is we're going to use twice as many straight lines going upwards. So what you're going to notice this time around, if I add in the extra lines in just a different colour, maybe blue. Okay, so what we can see here is there's extra lines going up in between the two values that we had there. So that means going up 0.5. Now, what we can see this time around is that, once again, when we do the joining up process, we can see that the area is a lot less, we're wasting a lot less area joining peak to peak. Okay? And so this means that the more intervals you have, the closer you are to the represented area. So we can see this time that it's a very small amount of area that we're leaving out. Okay, so we're going to do this one here, same type of table. So we're going to go mode, table, and we're going to go f of x is still the same equation, square root of 25 minus x squared. Now we're going to start at 0, end at 5, go up in a step of 0.5. Now we can see all these values here. Once again, corrected 2 decimal places, so it's going to be 4.97, 4.97, 4.9. Then this one here is going to be 1.5, which is 4.77. Then the next one, which is 2, which is going to be 4.58. And 2.5, which is going to be 4.33. Then 3.5, which is going to be 3.57. Then we have the number 4, which is 3. And then 4.5, which is 2.179. 2.179 is 2.18. So, like last time, we're going to use the trapezoidal rule. And we're going to use this y1 and yn are basically the first one and the last one. So it's going to be 5 and 0 again. Okay, so A is going to be, now this time our width is no longer in ones, it's in 0.5. So it's going to be 0.5 divided by 2, the square root of 5 plus 0 like last time, except this time it's going to be 2 multiplied by every other number, so it's going to be 4.97 plus 4.9 plus 4.77 plus 4.58 plus 4.33 plus 4 plus 3.57 plus 3 plus 2.18. So in this scenario it might be best just to add all these together first before we put it into the formula. Okay, so what we're going to do is get 4.98, 4.97. So let's start off with this. 4.97 plus 4.9 plus 4.77 plus 4.58 plus 4.33 plus 4 plus 3.57 plus 3 plus 2.18. Press equals there, and what we're going to get is 36.3. So the area, now this here equals a quarter, so it's going to be a quarter of 5 plus 2 times 36.3. Now that we're in this, what we can do is just add the two of these together, so it's going to be 5 plus 2 times 36.3. Then what we're going to do here is there's our answer, 77.6. Now we're going to divide that by 4. And what we should get is 19.4. So the area equals 19.4 units squared. Now what we can see here is that the area has gone up from the last value of 19.89 to 19.4. This means that it's basically, there's less underestimation, there's less waste as described by a shaded in region. Okay. Now find the exact area of the shaded region. Well, the exact area it's a quarter of a circle, so it's a quarter pi r squared. The radius is 5, so it's going to be a quarter pi times 5 squared. Okay, so what that's going to be is 1/4. Then you have pi times 5 squared. And what we're going to get here is 19.63635. So we know that the area is 19.635. The exact area is 19.635 units squared. So we can see that the estimation using 10 intervals was much closer than that of the one using 5 intervals. Okay. Now, use your answers from part 3 and 4 to estimate pi to 1 decimal. Okay, so our answers from parts 3 and 4 is we're going to get pi r squared, and we're not going to use pi from our calculator. Okay, and our first area for part 3 was 18.98. We know that the radius is 5 squared, which is 25. So pi equals 18.98. So 25 pi equals 18.98. So bring the 25 underneath, and we're going to get 18.98 divided by 25. Oh, sorry, it's a quarter pi r squared. Excuse me, it's a quarter pi r squared. So quarter pi equals 18.98 divided by 25, and now we've got to multiply that answer by 4 to get the answer for pi. So we're going to get 18.98 divided by 25. Sorry, divided by 25. Multiply by 4. And we get here is 3.037. So pi for this one is 3.037. It's way off the 3.14 that we're looking for. Now let's try the same thing again. Quarter pi r squared, or quarter, or basically the same thing, which is going to be 25 pi over 4. Okay, because pi squared is 25, and we know for the second one it equals 19.4. And in this case, we're going to multiply 19.4, multiply by 4, divide by 25, equals pi. Now the multiplication by 4 can be just bracket 4. So just do this out. So 19.4, bracket 4, and then we're going to divide it by 25. And we see there 3.104, much closer to the value of pi. Okay, moving on to the next question, which is question 5. Estimate the area of the curve of f of x equals x cubed between 1 and 4. Okay, what I'm going to do is we're just going to put this into the calculator. So I'm going to mode table function. We're going to get x cubed, and we're going to start at 1, end at 4, going to step at 1. So what we get here is 1128 327 464. So just make a quick table here. So what we're going to get is the x values, 1, 2, 3 and 4. The f of x values, which are going to be 1, 8, 27 and 64. Now what we can see here by this graph is that we can see that at this point in time the values 1, 2, 3 and 4, we can see that there's a really large growth in the table. You can see that the space is getting bigger every time, so it's going to be a type of curve like this. Okay, something along the lines of that. Now we're going to use the trapezoidal rule to estimate the area underneath this curve. So what we do is we can estimate the height. So we have 4 heights. It's going to be y1, y2, y3 and y4. Okay, so the trapezoidal rule once again equals h over 2. It's going to be your first one, y1 plus y4, first plus last, plus 2 times the remaining, which is y2 plus y3. Now the space in h is 1. So a is going to equal a half, y1 is 1, y4 is 64. Okay, y3, and then it's going to be 2 times y2 plus y3, which is a plus 27. So what we do is put all that into the calculator. So we can get is 0.5, bracket 1 plus 64 is 65. 65 plus 2 times a plus 27, close bracket twice, and what we're going to get is 67.5 for that area. And did I have it? Yeah, 67.5. 67.5 units squared. Okay, moving on. Number 7. The curve 1 divided by 1 plus x squared is shown in the domain minus 3 less than x less than 3. Estimate the area of the shaded region using the trapezoidal rule. Give your answer as a fraction. Okay, so we're looking at here, once again, table function. Then we have 1 divided by 1 plus x squared. Okay, we're going to start at minus 3, and we're going to end at 3. And I can write down all the heights here. So what you're going to get is 0.1, 0.2, 0.1, 0.2, 0.5, 1. And then you're going to get 0.5, 0.5, 0.2, 0.1. We're going to use the trapezoidal rule, which is a half, the first plus the last. So remember, the first one is 0.1, the last one is 0.1. So first plus last is 0.1 plus 0.1, or basically y1, y2, y3, y4, y5, y6, y7. It's y1 plus y7. Okay? Now, plus 2 times the remaining, which is going to be 0.2 plus 0.5 plus 1 plus 0.5 plus 0.2. Close bracket. So what we're going to have is a half of 0.2. Then we add all this together, we're going to get the first 3 is 1.7. 1.7 plus 0.7 is 2.4. 2 times 2.4. Okay? And what that's going to get me is a half of 4.8 plus 0.2, which is 5. A half of 5 is 2.5. So it's going to be 2.5 units squared. Now, please bear in mind the region that we wasted here, because we're doing the trapezoidal rule, we're aiming directly across, and you can see that some of the area is going to be left out in this question. Okay, the area above the dotted line here has been left out, so we have an underestimation. Okay, now the actual area of the shaded region is 2 tan inverse 3. So let's figure out what 2 tan inverse 3 is. So we're looking for percentage error 2 tan inverse 3. So that's going to be 100 ands. Now it's in degrees. Okay, so you got to change that to radians, because it's clearly not 143. So we go to shift setup, we change it to radians. So we try this again. 2 tan inverse 3, and there we go. The actual one is 2.498. So it turns out we seem to have an overestimation. 2.498. So 2.498. So what must have happened there was maybe the trapezoid. What could have happened was if you had your curve, okay, and you have 2 points here and here, maybe what happened was the trapezoidal rule went over the curve and hence created an overestimation. Okay? Now once the percentage error in your estimation, right, so percentage error, percentage error equals error divided by original value multiplied by 100 over 1. Okay, so what we get is error divided by original value equals 100 over 1. So the error is going to be 2 tan inverse 3 minus, so it's going to be 2.5 minus 2 tan inverse 3, which was the answer for the last part. So let's press the button here. It's in scientific mode, so we'll just do it as 2.5 minus 0.498, so we're going to get 0.002. Original value is 2.498. Multiply that by 100 over 1. So 0.002 divided by 2.498. Multiply that by 100. So the error here is 0.08%. We did multiply by 100, so it's 0.08%. So that's very accurate. Okay? Now, comment on the accuracy of the estimation. It's extremely accurate because it's less than 1% of an error. It's 0.08. 8/100ths of an error means it's extremely accurate. Okay? And finally, the total area of the curve under the curve is pi units. Find the percentage error correct to 2 decimal places using your answer from part 1 as an estimate for total area. Well, the area is pi, which is this number here. So pi, take away our answer of 2.5. Sorry. Pi take away 2.5. And what this means is that the error is 0.64, right? So error this time is 0.64. The true value is pi, and then we're going to multiply that by 100 over 1. Okay, so 0.64 divided by pi, multiply by 100, and this time it's a 20.37% error. Okay.